Okay, we're now to the section where we want to be able to look at data, decide if it's linear or exponential, and if it is one or the other, we should be able to write down the equation. I'm going to break this in two parts and do each kind of data differently, just so you don't have to watch a whole video for just one kind. So I'm going to look at some of the data right here. I have x running from -8 to 9.5. I've got f of x running from -18.5 to 32.25. The very first thing you should do when you're looking at data and you're trying to decide what kind of data it is to graph it, right? Now, I don't like the way Google Docs graphs data, so what I'm going to do is I'm going to go over Desmos, and you can see I've already plotted the points. You can see I have a terrible graph over here, and that's because that's just the standard way of plotting the points. What I wanted to do is to what's called zoom fit. Now you can get it to do that by coming way over here, and you see this little magnifying glass over here. And when you click on that, you see click, and you actually get to see what the graph looks like. Oh boy, this graph looks linear. And that's not a proof that it's linear. Once we decide that it's probably linear, I'm going to go back to the data and do the things I'm supposed to do to make sure the data is linear. So now I'm going to go back to the data over at Google Docs. And I know how to check to see if data is linear. I'm supposed to look at all the differences. So I'm going to go to the second cell right here. I'm going to type in equals, and then this y value, and then a minus, and then this y value. And I can see that first difference is 5.075. Now remember how we actually calculate all the others. We let Google Docs do it. I'm going to go click on that cell. I take my arrow and I go over to the little blue dot until it turns like a cross. And I bring it down. Come on, we can do this. Yay. And I go like this. And you can see that all the differences are constant. So yay, this is linear. Now once we decide if it's linear, what we're supposed to do is to try to find an equation. Well, I need the slope. I can't do this for exponential, but I can do it here. I'm going to let Google Docs calculate the slope. I'm going to write m equals, I'm hoping I won't ruin anything. I'll put equals, and I know how I'm supposed to find slope. It's supposed to be this y value minus this y value, parentheses, divided by parentheses, and then this x value minus this x value, like that. Yeah, so the slope is just 2.9. Now what I'm going to do is just shift cameras over here just to write something down. Let me just pick a point here. The nicest point I can see is -1, 1.8. So in just a minute, I'm going to go over to my whiteboard. I'm going to write down -1, 1.8. I'm going down to write down the slope equals 2.9. And now I'm going to shift cameras, and hopefully there's not going to be too much wrangling here. There it is, like that. Yay! Once someone gives me the point and the slope, we can write down the equation very, very easily, because we know y minus y naught equals m times x minus x naught, and I'm just going to put the stuff in. This is just going to be y minus 1.8 equals 2.9 times x minus x naught. In this case, that's x plus 1. And we have our equation of our line. So we looked at it, we decided it was linear. Once we decided it was linear, and we checked it was linear, and then we found the slope, and then we just use the point slope formula, and we're all happy. Yay! That's the end of part 1.